Good. Okay, so we started this. Obviously, we did one or two things. We started routing things that we were working on last week, and in the end, let me duplicate this. I'll share this also in the chat. This delete. In the end, we got to here. Okay. Bye. In the end, we got to here. No, I need to put this there back. Delete. Need to put this there back. So what I'm going to do is I'm going to let everybody create one VPC with two subnets, yeah, on AWS, okay? Because I need to confirm where we got to, okay? So we all understood last week that a VPC should have the following. Okay, so this is a VPC on AWS. This is a simple network, and we understood also that this simple network. Give me 1 minute. Give me 1 minute. Just 1 minute. Okay, so this is what we learned last week. We learned about a network being this green line here, and in AWS we call it virtual private cloud. In your home, this is your house. The green one is your house. Okay, in your office, the green one is your office building. Oh, go back. Yeah, is the office building, and that's a network. So there's a bigger network that you've created, and that represents, in my idea, your house, your home, your office. Could be the whole world. It could be your country's network. It could be anything. Okay, so a network is one big bucket that you have created. In there, you have an internet gateway. An internet gateway, we said, was, example, your router that your internet service provider gives you, which gives you access to the internet, hence the name internet gateway. Okay. Without that, your network, the green one, will not have access to the outside world. So the global network has its own, it's a network, and you are creating a subnet. So the green one is a subnet in the global network. You're creating a subnet in the global network, and every subnet requires a router. Okay, so even in your own network, the green one, you created subnets in there, yeah, and those subnets requires routers. Okay, so this internet gateway is a router that you are attaching to your network so that it can be part of the global network, the whole world's network, okay, or your country's network. Okay, so every network requires a device that will allow it to join that bigger network. Okay, so here we then created our green, which is our own network, and then in there we're creating subnets, the sub networks. Okay, and those are the blue ones here. Okay, and those ones, when we finished creating it, we created a router and we attached those routers to it. Now in AWS, these are not called routers, they are called route tables. Okay, route tables, the same concept. And then after that, you come in, and then, so this is the route table. Basically, it's a router. And then you can then create your devices. okay, in the subnet. And we did that, okay? So what we're going to do is to practice up to this end. And then after that, we do the security part. But maybe, I think before you can create all of this, you need a security. Let's do the security first. All right. So we all know that, let's go on with the security, and then we can practice creating the whole network, including the security and everything. We all know that, obviously, in the network that you've created, or the AWS cloud or the data center that you have been provided, been given to you, is over the internet. That's the first thing. You can set up your own data center in your house. Okay, you can go and buy a big rack, buy your own devices, your servers, your everything in your house, and you can do it your own data center and install your application on it and everything. Good thing is, because you are there at the data center, you can have control over it. You can literally plug anything into it, and so on and so forth. But for AWS, they give it to you. It's called a public cloud. They give it to you over the internet. So to access that data center, you need internet before you can access the resources on that data center. Okay, so this network that you create is an abstract. Okay, it's an abstract. Even your own network that you do in your house, if you want other people to access it, that's where the problem comes. Okay, other people, not just you and your family in your house, others. Also, you need to make sure that while you and your family in your house can access that network you've created, or that rack that you've created in your house, you need to make sure that nobody else can also try means to access it from outside your house. Okay, so this is it. Okay, now there's something called defense in depth. Okay, defense in depth. And I'm going to take you through, before we get to the network part, I'm going to take you through the broader security of a data center, and hence the goal is to protect data. Data, that's it. When you're doing security, network security, whatever security, whatever, your goal is to make sure that this data doesn't get into the wrong hands. That's it. All the security that everybody is going to learn, and it's just this. You protect data at the bottom there. Okay. Now, to protect the data, there are layers of security. Okay. Now, the first one is the physical security of your rack itself, or your data center itself, because that's where the physical drives, the physical servers, the physical everything is. You don't want someone coming to literally take them all and go. It's like, let's look at your laptop is the data center. You want to be able to protect that laptop, because that's where your disk and everything will be hosted. Okay, so it's protected. Some of the protection can be even power, internet, cooling, because all of these can impact the data. Okay, it can impact the data, and also physically making sure that the people who are allowed to come in are the only ones that come in. Okay, so that physical, when it comes to public cloud, AWS provides that for us. Okay, well, they say they provide that for us. Okay, and then when you create an account in AWS, which we've all created accounts, you also realize that you can't do it all by yourself, because creating a network, if you have a company and creating a network, creating computers, looking after it and all that, you can't do it all by yourself. So you will need people to come in as well in that AWS account that you have created. So AWS gives you access to their data center through the web, through the console. You click here and it will do this for you. You click there, and we've been doing some of that, isn't it? So there's identity and access, okay, where I give you access to some of the items, and that's one thing that we have to learn after networking is how do we manage our account to allow those who need what access to which tools on AWS. And that's another course. It's something that people should pay more attention to. Okay. And then obviously the perimeter is when you've got your network. Let's go back. When you've got your network, people still try through your internet gateway to try and access this using things like DDoS, and so on and so forth. So there is other type of security that you provide outside your network. Basically, in the military, again, because I'm ex-military, when we have a FOB, a military base, FOB, forwarding operating center, sometimes we, the military, we go outside and patrol the FOB. And some people will be patrolling around the network. Even though the gate, which is the internet gateway, is also protected, we go around it and protect things around it, just in case someone is trying to come it through using other means that we haven't protected within the network, okay, within the network. So something like denial of service, we've got something like WAF. Those are different types of networking that you will learn as well. And then we get to the network itself, and which is what we're going to do today. How do we secure the network and the resources? So in the network, you'll have your compute application and the data. Okay, so that's what we're going to do today. How do we secure the network, the compute, okay, and so on and so forth. So if someone somehow got in from here, we can still restrict them. But remember, at each stage, someone can bypass, let's say, the physical security, because its purpose is different. Okay, someone can bypass identity and access because obviously it's protecting something else, and so on and so forth. So someone can actually through bypass all top three and enter your network directly, because if you open the network to the public, it doesn't matter how much security AWS is providing, identity access is providing, it doesn't matter how much perimeter security you've provided, you've let them in through the network stage, okay? Because you neglected the network, someone came in through that, okay? And so on and so forth. So network is very important. You could also secure the compute, the server itself. So if they come in from there, they still need username and password to enter your compute, and so on and so forth. The application as well, because you want the application to go via the network and to other people. When someone sees the application online, you need to also protect the application, isn't it? So that people are not accessing the application, using the application to access the data. And even people can actually go directly to the data to go and access it. If the data, you don't secure the data as well, okay? So this is what security is all about. I'll let people ask questions and then we go on. Any questions? Is it very clear enough? Today we got full house. Seems clear. Nobody has any questions. Good. Right. So we are going to focus on the networking. Let's go back one. right? One part of a network, the perimeter or the green network, to protect it is to remove that. In fact, let me bring this here. If I remove this, that's it. Everything is internal. That's the first thing. End of. if the network itself is not publicly accessible, you literally have to physically go in or find a way to get in here. That's it. You have secured it. That's a private network. Okay, it's completely private. You have to find a way to get in.
Is this when they say we've taken down um our our website or something like that? Is that how they do it?
No. So when they want to take down the website, they go. I think they will go to the application level, and the URL that you're using to access there. So if it's gov.com, when you type gov.com, they will redirect you to somewhere else, which is not the application. And you will see something else, and information saying the website is currently not available. This morning I was literally doing a project like that for my company, which I have just completed. So basically, I need to take down one website, and this is the website. When people went in to use this URL, they were able to access our application. This is the endpoint. This is the access to the application. What I've done is now, even if they have this here, before it will go straight to the application for them to see the application. Now, when they do it, it says it will not go there. I have taken down the application, but the application is still sitting there running. Just that the path for you to come there, it's like going to Google and asking Google that, how do I get to London? And now Google has been told to direct you to Manchester. You get it? So that's another way of securing it. The path has been rerouted somewhere else, and you get confused as to. So this is not the application. This is another website that I'm pointing the URL to. So you can't come in because I have access to that. So I've just literally, this is what I was doing this morning, archiving some of our website and pointing the URL to site archive. I could say site is down. I could do anything. But while I fix the root cause, I'm redirecting you to somewhere else to give you some sort of information. And then when I finish fixing the issue, I point it back to the application and I say, hey, the application is back online. Now you can access it. That's one way of doing it. Okay. So, but we're talking about a network. As I said, there's an application and there's a network. So the question you ask could be that the application is being manipulated here. Okay, the application level security. Okay, right. No, not you. All right. So when I have removed this, access to this, everything in here. Remember, those in can also not go out. This is the problem. A server in can also not go out. A server out can also not access this in. Okay, so it's important if you need access out of this network, this is what your route out. If you need access in, this is your routing. So that's the first thing you can do. Okay, but you need to find a way to get in and out. And there are tools to allow you to do that. That you plug on the side somewhere and still get access that nobody else knows, and you can manage that from your own self. Okay, and that's how we have private subnets and public subnets. Okay, now when you come into the network, you've now got the access into the network by attaching a route table, internet gateway. When you get in, there are different subnets. Okay, and that's why AWS tells you that a network on AWS must have one subnet. Must have one subnet. Okay. The subnet level, you can also control the subnet level security, meaning that if I apply security to the whole of this subnet, it means everybody in here is abiding by that security at the top. So if I say, I will not allow someone coming in on port 30 to come in, that's it. No matter what I do to these applications at the subnet level, I have blocked access to that port. I've just used a word that most of you might not know. We could go into it later and explain what a port is and so on and so forth. But I have just told at this subnet level that nobody can come in. Now, in this level, subnet level, you can create multiple subnets. One can be a public subnet, one can be a private subnet, like you can see here. Go on private subnet and go on public subnet. A private subnet is a subnet that doesn't have any route to the internet again. As long as you don't have any route out and in to the internet, then you are private. Okay, so if I don't want anybody here to access if I don't want anybody to access any machines in this subnet, I just don't allow it to go outside. I don't configure it so that it attaches itself to this internet gateway. If I configure this network and I attach it to this internet gateway, then it becomes a public subnet. Simple. That's all. If you have access to the outside world, you are public. If you don't have access to outside world, you are private. And it happened as we did here. We removed this, it's a private. You add it, it's a public. You attach something here to this, it becomes public. You remove the access, it becomes private. So if someone gets in here through this, they have to find another way of getting in here, because there wasn't any. They got in, but their traffic can't come into this private subnet to get stuck here. Okay, so that's that one. So we have secured the whole network green. We have some way of securing it. And then we come into the network, we have subnet, and we know how to secure it using network access control list. This is a list again. A list of table that tells you who and what can access this network. They call it network access control list. The networking gurus will call it NACL. Okay, NACL, the network access control list. The name says network access control list. It's easy, unless you call it NACL and then you forget that it's a network access control list. So it's a list. On that list, and the network will also have a router, a route table. Okay, route table. So both of them, managing both of them together, the route table and the network access control list, you can specify or configure who and what can come into the network and how they can come in. Okay, use two of them. And it's applied to the network. So everything you do there will apply to everything in the network, no matter what. Okay, you blocked it, it's blocked. And when you get into the network subnet, you get in, let's say you have managed to come from here, and now you are here, and you got in. Yeah, you got in. Somehow you got in. This machine also can be secured. When someone is in, are they allowed to access this machine or that machine or any other machine in this network. That's the compute level network security. Okay. One of them is called firewalls. You've heard those words before. You put a firewall in front of the machine. Okay. And you configure that firewall as to who and what can come into that machine as well, specifically to that machine. Okay. And when you bypass that firewall as well, if let's say I allow you access to my machine, I allow you access to my green network, I allow you access to my blue network, and I allow you access past my firewall, I could also go into the application, the machine inside the application, and still block you on what you can and can't do there too, to that level. This is what this here was all about. Okay. And even when you get to the application, into the machine, the compute, I can actually also say in this machine, you can't access Postgres, which is the database server running. You can't access Nginx. You can't do this. And you all know Windows. When someone has got into Windows, what can they do? What can't they do? That's application level or operating system level. Yeah. Good. Any questions so far? No. Now, in AWS, firewall.
Can you secure the router, or it's only this the things you access through the router you can secure?
Yes, only the things to access through the router. Router itself can be, it's like when you have an umbrella, and a router is an umbrella. When it's raining, the rain can touch the umbrella. Okay, so people can access internet gateways. They will try and throw stones at it or try and enter. People are always trying, trust me. There are people whose job is sat there trying to enter. They're running scripts, they're doing all sorts, trying to enter. Even your own home network, people are trying to enter. There are people trying. It doesn't mean they can't get there. So I use an umbrella. The rain, when it's raining, will touch your umbrella. Okay, so internet gateways are not immune to attacks. But can it go through and touch you? That's where you need to toughen your security. That's what all security is about. Because we know people will try. And there's no way I can put another dome on top of my umbrella, is it? Can't cover the umbrella again because I don't want the rain to touch it. So network security is important because we know they are visible to the world, because you want people to see it anyway, to come and get your data. All you want is, you don't want the wrong people to come and have your data. That's it. Okay, so you need to allow the rain to come in, but you need to be able to make sure that this drop of rain, only you, this drop of rain, come in and touch me through the umbrella. Only you, and only you. And I need to make sure that only you can come in through the umbrella, not all the rain that's coming in, trying to touch. Yeah. So yeah, does that answer your question?
Yeah.
Good. Okay. So in AWS, the firewall is called a security group. 1 minute. There's an alarm beeping. 1 minute. 1 minute. So sorry about that. In AWS, we call it a security group. Okay. Now, when you create a security group, where are they? That's not a security group. Oh no. Undo. No. That's a security group. When you create a security group, it applies to the whole network. Okay, so the way AWS did it was that I'll create a firewall, but I'll create it as a container and I'll put it here. Okay, so I'll put it here. In this network, this is a security group. Okay, a firewall. Any machine attached to this in this green network is behind this firewall. The good thing is you can create numerous security groups. You can create plenty security groups. The point here is the security group that you create can be used by any machine in this network, the whole green network. Okay, not this. The way you explain it, sometimes it looks like this. Okay, it looks like this. It looks like it's a firewall for this EC2. You can do that. You can create one for each machine. As I say, there's a limit as to how many you can create, but you can create one for each machine. But my point is, if I want to attach this also to this firewall, oh no, if I want to attach this also to this firewall, I can. If I want to put, so the way I explain it is that in AWS, a firewall is literally a big wall in your network that you can move all your machines and put them behind. Okay, so here I can say which one? Okay, let's do this. This is a big wall, isn't it? Okay, so I have a wall, and I can say that, okay, in this wall, I'll leave it here. This machine is behind that wall. That machine is behind that wall. That machine is behind that wall. Yeah, that's a security group. So you could create one security group and attach it to it, all of them. Okay. Now, one other item is a port. A port. I explained a port to the team in long ago, but obviously we got a lot of people here. So what is a port? Anybody apart from John Luke, Alphonse, Anthony, Paul, Chris, when you hear the word port, what comes into your head? Forget about computing. Port. Can someone tell me anything? Port. You hear the word port. What comes to your head? Covenant.
Port can be, I don't know, maybe a bit technical. Port can be a noun or a verb. You can port something, which means you move something, and port could also be, I don't know, in very literal term, just something you plug into.
Yep. It could also be the port where the ships come in.
It could also be that too, yes.
It could also be the port where you land your airplane. Yeah?
Correct. Yeah, that too.
Yeah. So that's a port. If you look at a port from that angle, and then we say UK is a machine. UK is a machine, yeah? It's a machine. a Linux machine or a Windows machine, we have, how many ports do we have in the UK? Numerous. We have Calais. If someone wants to come into UK, they can come via Calais. Someone wants to come into UK, they can come via Heathrow, Birmingham Airport. They can go via Southampton Airport as a ship. They will go using a ship. Someone will fly in, and someone can enter via land as well. Well, UK doesn't have land. They all have to come via sea. Instead, either sea or air. Okay, but if you go to someone like Belgium, you can actually enter via land as well. Yeah. So, like Ghana, you can enter sea, air, and land. Okay. So these are ports. Every computer has its own ports. And the same as the UK, each port have its own purpose of exactly what, when you come in, you can and can't do. You can bring and can't bring. You can't land a ship in Heathrow. You can't bring a ship through Heathrow. Same way you can't you can't go to Calais with the plane. You can come by a small boats, dinghies, but that has its own complications because obviously things will happen to you, and if you die on there, you die. Okay, so that's the port, and every computer has its own port. So when you are accessing your browser, when you go and put www.gov.co.uk, and you are actually sending a request to a machine to share some information with you. We can try that. Okay, so we go here. We are using a browser. Remember, we are using a browser, and then in the browser, we know we have an information of a path or a domain or something that will take us to somewhere. And remember, all of these that you put on your browser, there's a computer sitting somewhere listening to it, and it's so fast that you feel like you don't even see. It's listening to it's called a request. It's listening to the request and giving you back what you want. And the browser and the computer are working together to display the information to you. So gov, every time I use gov.co, because it can never go down because it's a government website. Can't go down. Oh, maybe, is it called gov?
.gov.
Oh, it's a .gov.
Gov. I think it's gov.uk or something.
Gov.uk. Oh, yes. So this website here, I have sent a request to this whatever machine sitting behind this URL here. And I said, give me your information you have. And this is the landing page. So when you enter, they give you, this is the home, the root. This is the first thing that you see. Okay. But the server is serving it. It's a server giving me this information, and the browser is displaying it for me. So the information coming from the server is not blue, white here, and all of this. Basically, the instructions was given to the server, the browser, and the browser has rendered that information in a very nice way for me. The browser and the script that the browser is running, and also, so my browser is also doing work. You got the information, it's also doing work, and hence I'm able to see all of this. Okay. Now, for a browser to go to a machine to go and get information, they use two different ports. Two basic ports. Port 80. So when they are going to the machine, they have to enter the machine through port 80. So basically, what's happening is so nice. I love this. what's happening is we have gone to the compute. We want the application. Okay. And this application is a server, is serving content. When we are entering the compute, we have managed to go bypass all of this. We've gone to the network and we've gone to the computer. Even there, we are entering via a port. And the computer has blocked all other ports and allowed access through that port. So now we have literally done all that we can. Go back. We've done all that we can here. And we got to the computer. Even that, we set which port you can access which application on. So something like a database server running on the machine. Okay. Let's say this is a database server running on the machine. And one of the database servers are like Postgres. Postgres is a database server. You can only come in through port 5432. That's the port number. And if you don't specify that port, you will not enter. You will not enter. It's like I'm going to UK and I'm just at the top. I've flown into UK. I want to land, and I want to land at any port. No, you need to let us know which one you want to come in, and we will check if you're allowed or not. Other than that, if you try and land, these people will shoot you down. That's the security of UK. You fly in, by the time you enter, the flight needs to tell it where it's going, when it's going to arrive, what he wants, and what he's bringing. And that's what happens every day. Even when you're taken out, you need to know. Okay, so that's another level. So we've gone in through the internet, through the network, we came through the router, but by the time we are coming, we should have information as to when we get to the server, which port we are going. So we can actually block that port number at the network level and say, if someone comes in and they want to go to this port, don't let them. It's blocked. Everybody can come in. They need to have something telling us that they want to go to port 80. And then we check at the top here and we say, oh, this person is allowed to come in and he's actually only accessing port 80. And then we let them in. When they get here to the machine, it's only port 80 the machine will allow it to, because you said you want port 80. When you get to the machine is also configured that when you come in as port 80, this is what you can and can't do. You can come in, check this. This application will so help you with the information you want, and you get back out. It gives you the request, what you want, and you get back out. That's what port 80 has been configured to. So every browser has, when you send a request to a machine through any browser, yeah, by default, the browser is going to request to go to port 80 or port 443 of each machine. There are two ports the browser use by default, because this can be changed. As soon as you change it, you need to put the port number here. You need to put is it colon or semicolon? One of them. And then you specify the port number. Okay, I'm going to this machine, and when I'm going as this port. Okay, if I specify semicolon this port and I enter, because obviously it's the default already, it will work here. But if I put, let's say, port 5432, basically I can change the default by specifying my port, the port I want to go to. So that's one thing. I can create a website on my server and change the default port from 80 to my own pin code, because there's about 6 60-something thousand ports in a machine from their default ones. We can check ports, numbers, and everything in it. Obviously, Google knows that. So, but if I enter this now, because I'm saying I want to go to gov.uk on port 543, it should not work. As you can see, gov.uk is still spinning here. As you can see, it's not going to work. This gov.uk does not allow people to come into the server on port 4532. It's confused. It will stay there. The port is closed. Okay, it's like I can't come in, and you're there hovering. Can I come in? I can't come in. And then sometimes the browser takes a while before it spits out an error saying I couldn't get in through the server via that port. There are 2 ports, as I said, 80 default are 80 and 443. So every server will have that port, those ports open if you want them. The port 80 is not secured. So that's so HTTPS is saying that I'm going to port 443. Okay. HTTP is for port 80, which is not secure. So S means this port is secured. Without S, it means the port is not secured. So what some websites have done, if you remove the S, their system will redirect you to the secured one anyway. So if I enter now, you see, it says timed out. See, an error occurred during the connection to this port. Yeah, it will not work. But hey, if I put the default on the default 80, or let's say is it 443? Yeah. If I put this, it will work because it's the default anyway. You are saying you shouldn't have put it there, but you can. My point I want to explain to you is there are ports to every machine. Number of ports in total number of ports. In networking, let's see. 65,553 ports in one simple network. Okay. You can actually common ports. Hey, Google is now listening to me. My common ports will be, as we just discussed, port 80 used for unencrypted web traffic, HTTP used for encrypted web traffic, HTTPS. When you send an email, you're using the port 25. SMTP. When you want to connect to a machine, SSH, you're using port 20. For file transfer protocol, you're using port 21. For telnet, basically, there you go. Okay, so every computers have been configured that every port is for a specific application or protocol that you're using. All these protocols has been written years ago. Okay, remember, a protocol is a law that we've written, and when Microsoft does the computer, when they all embed all those things, and there are bodies that check these things. Okay. That doesn't mean these cannot change. You yourself, your application, you can change them. You can change them. But when you change it, you then have to tell the person that when they are accessing your website, they need to put this port, else they will not come in. The default has been changed. So by default, these are the ones. But you can change all of them to a different number that no one knows. And that's another way of securing yourself. Okay. So, in a nutshell, there are ports. And on the firewall, at the firewall level, there are 2 things. I can say that when someone is coming into my machine and they have this IP address. So remember, everybody has an IP address. So remember when we talked about packets, when the packet is coming, it has information about where it's coming from, the port that it wants it's also in the packet. So when I'm sending the information, I'm sending a request, I have all this information. My port that I'm coming in as, I want my IP address. So when this browser, I went there and I said gov.com, my request that went in, and one thing that you can look in any browser is something called inspect. Okay, inspect will show you some things. No, not you. Inspect will show you what's happening in the back end of a browser. Okay, so here I can go to network, and if I refresh this, let me also, if you haven't seen inspect before, today is your lucky day. Then let's refresh this. So everything that's happening in the back end, this browser is doing all of these things in the back end. Yeah. And before it serves you, this is what it did. Okay, you can actually those who knows inspect, I know John Luke, you know a lot. I want to find the port number. John Luke, this is where you live. Okay, so here you see, this is the response code that was given me. You see HTTPS. It went as HTTP first, and I think it got redirected to HTTPS or something like that. So these are information that the request comes with, and so this is the head. So this is the request. And that's the response. All of them. I don't want to get into these yet, but as I say, even the code that this front end is doing is publicly accessible. You can find all of that. Okay. So this is the GET request this year. This is the whole GET request, and you got a picture, you got also, and then this is rendering all of that, and so on and so forth. Okay. So any questions so far?
My question is obviously there's a use for it, which is the unsecured port, which is port 80.
Mm-hmm.
I want to know the particular use for creating a secured one and an unsecured one.
Similar question.
Okay, so I think what happened, and I haven't, a YouTube, simple YouTube video can help us there. These tools that are there has always been improved, and at the beginning, that was the protocol that was generated, which is the HTTP. Okay, and when they finally found a secure way of doing it, they did the HTTPS. One other thing is, for HTTPS, you need to spend a little bit more money or do something, because that's where we're talking about keys, isn't it? For the HTTPS, there's a key, private key, and a public key thing, because you are encrypting the secured one is that so when you put your username and password on a website, do you know it's literally username and password as a text, even though the browser doesn't want someone sat behind you to see. That's why it makes it ... But the request that is going, the information before your browser sends that information via the internet, that information, if you use HTTP, which is the not secured one, it's literally ABC text. Naked eye can see it. Anything is text. So a middleman in the middle could actually intercept that, and they will get all that information, your username and password, your driver's license, your bank details, your PIN, all that information you put there is put together and is sent to a server. So this is my information. So when they're asking you for your long number, literally, when you're putting it there, it's a text. And they ask you for this, your code, your peak, new, and the browser is going to take that information and give it to the server, and the server is going to say, oh yeah, I've got this. I'm going to use it to process a payment. If it's HTTP, man in the middle could intercept that packet, those packets, and they can get that information. But HTTPS encrypts it before it's sent via the network. So every website that you visit, like this one, when they are using HTTPS, this is the encryption key information. So that the padlock there, here, this padlock here, means that the data you're going to send to this machine will be encrypted in transit. Okay. And you can actually check the information of the encryption. Okay. So here I've come in, and then this website does not support ownership information. And this is the certificate, the keys and stuff. All of that information is here. Yeah. So they have, this is the encryption information, and this is the public key. So when I do this .com, I go to the machine and I get all the, my browser gets all this information, and it now has the public key. Okay. So when my browser is sending the information back to .gov.uk, it will use this key to perform an encryption and lock the thing. So it's only the server that has the private key to unlock this. So as soon as I went in, I've received public key, I've received all this information about this server. So the browser is going to use all these to encrypt your data before it sends it. And then when it gets to the machine obviously have the key to decrypt it. So this is what I think last week we were having a chat about. And that's why when you go to any website that actually doesn't have this padlock there, and they ask you for your username and password, don't put that. Don't put, because basically what you've done is like going to BBC and sitting there and telling them my password is ABCDEFGH, more or less, and my username is this. Okay, so be careful. Check if this padlock is locked. Sometimes if you are paranoid, you can actually also go and check the encryption information, view the certificate. This one certificate was verified. So there are bodies who actually also verify the certificate. You go and buy the certificate there, put it on the server. There are bodies who does that. And this one is Global Sign. Yeah. Global Sign. If you look at my website, which is pulse.bbox.com, it is also encrypted. Okay. It's also encrypted. And if you get to the information, you see that Amazon has verified this certificate. So you need a credible body to verify the certificate. There are other companies whose encryption is actually not verified. The encryption certificate is not verified. It's a bbox.com. It's verified. It was issued by Amazon and it's verified by Amazon. So the certificate is, and it's renewed every year. This certificate is renewed every year. Okay. So I hope it answers your question. The HTTP was already there. And I think sometimes if you're working in your own house, you don't need to go and buy a certificate or configure certificates, because these things you have to literally configure it for your website. Okay. Question answered. All right. Let's go and play with AWS. Okay. Now we know how to create a network. We know how to create subnets. We're going to add the security part. And then when we finish, we'll create a machine in the networks and see what we can and can't do with those machines. Okay. Everybody can log into their AWS account now. Those who can. And those who can, please go ahead and create a network using, I'm going to share the port number in the chat. no, not the port, the IP address we're all going to use in the chat. Okay. And then from there onwards, we'll see how we create our networks. There are how many people here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. But obviously, not everybody will do it. So, John Luke, you will create a network. John, everybody in Rwanda, please create a network with IP address range starting one. Is it 1 minute? 1 minute. 1 minute. Let me check something. Private IP address ranges, IP address. Yeah. So if you are in Rwanda, create with 10.0.0. But remember, one person to create with 10.1, the other person should create with 10.2 and 10.3. I don't want overlapping. Okay. If you are in UK, create with 172.16. Remember, for .16, the next one will be .17. The other one will be .18. Because obviously it starts from 172.16. So going forward, it will be 172.17.0.0 and so on and so forth. So when you pick one, just write it in this chart which one you picked, so that someone else will not pick it. The reason we are doing, and then keep this IP. The reason we are doing is when we get further, we are going to practice how I can connect my network with your network from my AWS account to your AWS account, because we're going to connect networks together. And how can we create a tunnel, a VPN tunnel between two networks, and then my PC can, even though it's not publicly accessible, can still talk to your PC. Okay. And to do that, we need to make sure that my IP address doesn't overlap with your IP address. Okay. And that's why I'm doing that. And then anybody else can also use the 192.168. The 192.168. But the next one, obviously, because it ranges from here to here. So it's going to be 192.168.1, .1, .2, .3. But the 192s, your IP address ranges will be very, very small. So your network will not have a lot of, but it doesn't matter. We're not going to create a lot of machines in the network anyway. So let me, where's the chat? Let me put it in WhatsApp, actually. No. So Rwanda will be 10.0.0.0/16. So these will be 10.1, yeah, .0. The beginning, the first one will be .0/16. So someone can take that one, yeah. And then the next person obviously will be the next one. Copy, paste, paste, and paste again. So the next one will be what? .2. So I'll just put .x here. Yeah. That's the Rwanda. You create a network, you can pick 10.0, 10.1, 10. Whatever going forward. If you are in UK, you can use the 172. Okay. And as you can see, it ranges from 172.16 up to 172.31. Okay. So that said, this is how you can do it. 172. UK 172. Copy. Comma. It will start from 17, comma 18, and so on and so forth. But remember, it's all /16. Yeah, /16. So pick one going forward. So here up to 32. This one will go up to 32. So 32 people, not 16 people can use it. Can pick this in UK, which we don't have 16 people. Yeah. And then if you are not in any of these countries, you are anywhere else, you use the smallest one. You're in anywhere else, use this one, which is from here to here. Remember, the next one after the first one will be, so this is the range. So the next one will be copy, will be, this is where it starts, 1. So the third octet is what's going to go up. Okay, the third octet. And as you can see, for the third octet, it says you can start from 0 to 255. 255. Okay. Not sure if we can do /16, but let's see. Okay, I'll be using the 192. Okay, so let's create our networks. You're creating a network, the green, and then after that, you're going to create 2 of the blues. Now, I want one of the blue to be a private network, and I want the other blue to be a public network. I'm going to obviously go through it as well with you so you can follow along. But the idea here is that you should be able to close your eyes and create these networks, at least on AWS. Yeah. And then if you want to practice more, you can then go to Azure and learn how to create these networks. You can go to Google Cloud and learn how to create these networks. Good thing is, well, I know for sure, everything we've done here, except this brown here, even we can get machines that are free. Even in Azure, can get machines that are free just to test. These will be free. Yeah. So make sure you're not spending money on these. Okay, it's free. Everything here except here are free, but even with the EC2s, we can get free ones. Okay, we can get free ones. All right, let's log into our AWS and create these networks. Willie. I will be asking for people to show me their network, so might as well start. I know one person who has traveled who cannot, but even that person, they should try. The travelers, they should still try and create the network. And if you have any issues, let me know. Cool. All right, so I'm logging into my AWS and I need my MFA. All of you haven't done MFA, so just log in. Get to AWS anyhow you know fit. Oh, and everything we do, we'll do it in a region. We'll discuss regions later, but always make sure that whatever you're doing, you are in North Virginia. North Virginia. So when you log in, you look at the top here, the top right corner, there will be a city name there. like so. Make sure it's North Virginia and Virginia. If you select, you click it, it will give you all the regions, all the cities that you want to create your data center, or you want to use the data center that is in that city. Okay. So some cities will have one or two or three. So here we got North Virginia, we got North Carolina, Ohio, Oregon. So these are the data centers in US. So US has 4 regions. Asia, that's okay, a lot more region. Canada, there's only one, and Europe. We've got South America. Oh, guess what? We got one in Africa, Cape Town. Okay. Even in Europe, we have Milan, Spain, and these are all the places that AWS has literally got physical buildings with machines in it as data centers, called data centers. Middle East, Bahrain, Zurich, Spain, Milan. Some of them are activated for you by default. The rest you have to physically go and that's why we've got managed regions and activate them. So if I want to spin up, use the South Africa data center, Cape Town, I have to literally activate it. Okay, you have to activate it. But hey, we are using North Virginia. For this course, as soon as you go to AWS, set in North Virginia. Okay. Where we create networks is this as AWS service called Virtual Private Cloud, VPC. Okay. So you go to the search bar or you go to services. You can view all services, and these are all the services that AWS provide. These are it's either called solutions or services. Okay, so it's a number of things coming together to provide this solution. So for networking, you go to VPC, or if you type networking, it will still bring you the VPC. Okay, you see, you've got networks. It's probably in VPC core network. They're all probably in VPC. AWS managed blockchain feature. Oh, we got blockchain with network knuckles, network access control list. They are in VPC. Okay, so yeah, what you need is a VPC. You need to learn these namings in Azure. It's called something else, but in AWS is called VPC, and the full name is Network Private Cloud. Okay, Network Private Cloud. What's the issue with AWS? Those who can't log into AWS, we can support you at any stage, at any level. So if I'm here and you can't do it, let me know and let's stop and help and support. Has everybody got here? If you haven't got here, can you raise your hand? Achina, you're not part of this. Okay. Kobe, can you share your screen and let's see what's going on?
Bernard, did you call me?
No.
Oh, okay, sorry.
Are you here yet?
Where I've created a VPC and the subnets. Yeah.
Oh, you finished? Ha!
Yeah.
Cool. So which subnet range did you use for your VPC? Can you share in the chat so that someone else doesn't pick it?
Okay.
So if someone has already used it, don't use that one.
So with the VPC, I used 172.18.
Okay.
Yes, /16, and then
Yes,
the subnet.
write it in the WhatsApp group. Write it in the WhatsApp group, and then so nobody will touch 18. Someone will have to do 19 or 20. Kobe, I'm really happy to help. If you can share what's going on. Do I need to stop sharing first? I think. Did we create the AWS account the other time?
Yes.
Okay. So let's see why you're having issues. It's easy. Sometimes you forget. Aha. Okay. Your username, you're using sign in as an IAM user. No. Go back to sign in as root user. So there's a link at the bottom here. And here it's easy. So you put your email address and the password. Okay. Email address you use. Remember, if you use the plus as well, you need to add it. Remember last time you need to add the plus as well. So the email address, exact email address you used to create the, good. Voila, the password is already there. So all you needed was that link. As I said, I know if I see it, I can fix it. Go down, keep your account secure. No, don't skip for now. We'll do all of that later. That's the IAM part. We'll be doing all of that later. So skip for now. And voila, you are in. Okay, let's continue. So remember, you are the root user. Okay, you are the root user. You've created the account. You can create AWS user accounts for me, Foster, everybody here to also come to your AWS account, and those people will log in as an AWS IAM user. For security reasons, AWS says that you should also create one for your own self and not use the root user. Root user should never be used. 3 things it can be used for: delete the account, and because the root user have access to do everything. So it's not best practice to use root user, but forget about it for now, because this AWS account, you're the only one who's going to use it anyway. For me, my AWS account, because I've got numerous, I don't use the root user. I have created a user for me. So you can come here and create a user for you with a new username and password, and that means you never use the root user again. That is the user you come in to use. So, but we're not doing that today. Okay. So you see where I showed you where the region is at the top right. No, top right. Yeah, you're in London now. So select North Virginia, which is at the top. And you always, every day, make sure that you are there. I think there's a setting somewhere that can help you with the default region. As soon as you log in, it takes you to North Virginia. But hey, I think AWS caches these things. So if you use North Virginia more, next time you log in, it will take you straight to North Virginia. So you are in the North Virginia region. And then you search for VPC. In the search bar at the top, top left, where it says services. Yep. And then you click on VPC, the blue VPC. Yeah. So it's taking you into the console to create networks. And this is it. Okay. So let me take over. You can stop sharing. Entire screen. This one. Okay. So this is the VPC for North Virginia console. Okay.
Where is it?
And as you can see, the yellow or orange top left, it says create one. I want to create a network, create a VPC. Okay. You select it, and we want VPC only. We could do VPC and more. Today, maybe let's do VPC and more, which means that they gives you access to select things easily. Okay, so that's a VPC and more. Or you can just create the VPC, which means that you yourself will have to configure everything going forward. Okay, and I think we should do VPC only so that we can actually practice what is needed conceptually before we can actually think, let AWS do it for us. All of this we are going to code. We're going to write a code to do this for us. Okay. Later on, we are going to do it remotely from your command line, and a code or a tool called, let's say, Ansible, Terraform, all of those tools that AWS DevOps use. We're going to get into those ones. We'll come and create these networks for you. It will manage the network for you. Okay, it's called configuration management tools. Hi, you're on a video, by the way. So I want people to know exactly what they are doing. So this is an easy way. It will do a lot of things for you. You say, so I want number of networks, you select, and then it just does it for you. But let's go and do it only. Okay. So we will call it your name. And so I'll just call it Bernard _ upon _ I'll put today's date, which is 12 October 24. Yeah, I'll put even time as well as 8:30. 08:30. So this is it. This is a simple way of identifying my VPC. It tells me it's for me, because when other people are looking at it, we are connecting networks together. We want to be able to identify these networks. Okay. I'm also going to use the CIDR, London People CIDR, which is the UK one. Someone has already used the 18, someone has used the 20. I'll use the 21. Okay. Or I'll use 19. So if I go back, it's 172.172.19.0.0. Okay. So I'm also taking this range. Okay. 4/16. All right. I'm not going to click it. I'll leave everything to be default. And that's it. Create VPC. So what we've done here is we just created the green. The green box has nothing. Nothing. It does come with some route table, which is a router. So basically, in this green box, every machine I create in it can talk to each other. So by default, it comes with a router. You see, when you see route table, it's literally a router. Okay. But they give you a table to manage the router. All you need in a router is to say, I remove this, I add this, and they give you a table to do that. We discussed tables last time. Okay. You can see the CIDR for this VPC. You can see the flow logs. If there's any logs coming into the network, you can see it from here. You have to configure it though. Tags. And if you do any integrations as well, you can see it here. Okay. And this is the map. It has nothing, no subnets. It has one route table, no connections. No connections means that it doesn't have any connection to the world. It doesn't have any connection to any other networks, nothing. Just a black box. All right. This black box here. Okay. That's it. It's just this black box. Green. That's what we do. So now we're going to create a subnet in it. Okay. We're going to create two subnets. So you go to the VPC again and you go to subnets, where it says subnets. Where is it? Subnet. There. Okay. So this is your VPC. You create subnets. Last time we did one. So let me actually go back to my VPCs and copy this name, because I need it to name my subnets. And then I go there. It says create a subnet. Now for a subnet, you need to select which VPC you want to put it in, because the subnet cannot sit all by itself. And I'm just going to name this one sub1. Yeah. And I'm going to make this private. Okay, call it private -1. Can be 3 private subnets, can be 4 private subnets. So when you're doing this, this is where you think about how you want to visualize it after, how you want to see it after. Okay, that's very, very important. Very, 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 very important. We talked about availability zones. I'm not going to do that now. Now, here is the VPC CIDR block. Now they want you to select the what's it called? So we'll probably do 172.19, yeah, and then you can skip the 0.
Put 192.
Well done. 172.19. We can skip the 0 and go to the last octet. Or let's see, let's start from here. .1.0. Will it work? And then we say 18. It has 16,000 IPs. Okay. Copy. But then where does it? I can add one more. Now this one, and AWS is good because it will tell you that this one is going to be public 1. I'm going to create a public 1, so I'll call it public 1. Public 1. So next time, if I create another one for public, I can call it public 2. If I create another public 3, and so on and so forth. Now, this is where the problem comes. How to know the next network range. Okay, how to know the network range. So here, this one will end where? And where, so this one, where does it end and start? And then that's why you go to your man and say, CIDR dot XYZ. I think that's someone's website. Yeah, you go there and then they will help you. Okay, so I'll go 172. Was it what 172.19.1.0 19.1.0/18. So it says that the first IP address will be this, and the last IP address will be that. Yeah. So what it means is, if I want to start again in the next network, this number has to go up. Okay, this number has to go up. So it's used everything 1 up to 63. Yeah. So that means that we used from 1 to 63. So the next one should be 64. Okay, 64. Or 63.255. So I'll do 64 dot 0. Let's see how that goes. But again, you can also 64.0/18. When you click create, it will tell you if it will work or not. But if you don't, it will not work. As I said, don't sit here and work yourself out how to get the IP addresses. You can just go into, at the moment, there are so many tools that can do it for you. So let's see. AWS will cry if it will not work. And it didn't cry. Oh no, we did it. Okay. So we created 2 subnets. Yeah. One public, one private. We didn't create an internet gateway though. Okay, so let's go back to our diagram. So we created a green and we created these. So let's create an internet gateway because we want our network to be publicly accessible. So let's create the internet gateway. If you use the other option, it would have done all of these things for you. Okay, so we go to internet gateway and then we create one. But I always go, because I know that I'm creating this internet gateway for this network, I copy the name of the network, and then I go to internet gateway, create an internet gateway, and put the same name there. Okay. Meaning that this gateway is for this network, and I create. Okay. So if you come to internet gateways, you see that now we have 4 internet gateways. One of them was blah, is detached. I can delete. Even if I don't delete, AWS is not going to charge me for it. These ones are attached to some networks, and this new one that I've just created has not been attached. Okay. So I then this is good for you to know when you're writing the script. So there's something called infrastructure management or infrastructure as code. All of this, you can do it as a code. And some of the tools will make sure that when you set it, it stays the same way. Because if someone comes here and make changes, you forget. Because all of these things, how can you say, hey, and do it every day? There are tools to manage it for you, okay, called infrastructure as code. Okay. So I select this. Now what I've done is I have created it, and it's there. I'm sorry. I have created this. Oh, what happened? Oh, this is a picture. Oh no. I was thinking this is a screenshot. Okay. I've created this, and it's there. It's on its own. I've named it the same name as the VPC, but I need to attach it. Remember, that's the thing. You need to attach it. You need to physically go to the shop, buy the router, and bring it to your home. Okay. It doesn't happen by magically. Yeah. So you have to physically attach it. So you select it, and you go to actions, and you say attach to VPC. And AWS will only give you the VPC that it can attach to. Yeah. And you attach internet gateway. Voila. Yeah. So now, if you go to internet gateways, you see that this new one that we created has been attached to this VPC. It's been attached. So what we've done again is, and we're going to finish at 9, please, guys. What we've done again is we physically took this and attached it to it. Okay, we have to attach it. Right. Now we've got to the bit where we've got these. Okay, so let's go into security, a bit more security. Okay, so there are route tables, and route tables, as I said, are routers. Yeah. As you can see, we did not create any route table for our subnets. So we need to create our own route tables. Okay, we need to create our own routers. The subnets that we created here, which are these ones, the public and the private. Okay, the public and the private do not have any route. So literally, if you look at route table, it doesn't. There was an error loading this table. There's no route table, so it didn't have one. Okay, it doesn't have any route table, so there's no router. It's a network with no router. Well, for some reason, AWS should have. Anyway, we're going to create one and attach it to it. Again, we're going to create a route table or a router and attach it to this network. Okay, so that everything that comes into that network will go through that router. All right, every router should have a every network should have a router if it wants to communicate outside or inside or to another network. We had that conversation last time. So we go to route tables, and again, the way I do it is I copy this again because it was not copied. Go to route table, and I create a route table. Okay, the route table name will be this, and it's going to be for which VPC? This VPC. Okay, route table settings, and create. All right, and then I'll create another one. Oh, I should have created this for the public, so I can rename it and call it public. So if I go there, I can rename this route table and call it public 1. So I can edit the tag because I want to be able to remember that this is public 1, public 1. Yeah. Then I'll create another one and call it private 1. Create another one and call it private 1 route table. Private 1. It's also in this VPC. So I created 2 route tables. If I go to route table, yeah. If I go here, what do I do? See, set main route tables, edit subnet association. So these routers, we need to then associate it to some subnets. Okay. So here, as you can see, okay, it chose a subnet to give it already. It chose the subnet. So these are the subnet. Okay, let's go back. It didn't choose any subnet. So this one is the public one. This is the public one. So when I go to here and I say edit subnet association, I want to associate it to the public one. Save association. Voila. I go to the next one. So we are physically attaching the router to the subnet. Go to the next one. I go to edit subnet association and I go to private 1 and I save association. Okay. So these route tables are now associated to these subnets. Okay. So you see, it's a route table, subnet association, this subnet, that subnet. And that's why it's good to name your things, because when you don't name it properly, when you're selecting these things, you get confused which one is which. Okay. So we've associated the route tables. And so now if we go to our VPC and we go to, there's a resource map, AWS has done that, you will see what's going on visually. So this is the VPC. These are the subnet, 2 subnets. One of them has a router going here, and the other one also has a router going here. End of. The big VPC here has 2 subnets. This subnet will route its traffic via this router. And this subnet will route its traffic via this router. Remember, so far, both of them, nobody can go outside. There's no connection between any of them. So everything here is now still private. This has been attached, but when it gets into the network, nobody can go into these subnets. So if I put a machine in one of these subnets, there's no link. And as again, a private subnet is a subnet, or a private network is a subnet that doesn't have any association to the world. So what we have to do is associate one of these routers to the world, and that one will become the public one. So that's what we're going to do. So route table, we go to route table, which is these routers that we created, and then we go to the public one. Okay. Now, the public one, we need to edit the route. Okay. So it says local. Everything in here should be local. What we do is we edit route, and then we add one more route. People call it route. And we say for everything, anything, port, IP address. There's one IP address that the whole world they created. IP address. Okay. Every machine has an IP address, but this IP address here, 0.0.0.0/0 is an IP address. That means that every IP address, it represents every IP address. So what I'm saying is every IP address is allowed. Every IP address. So when you put 0.0.0.0/0, it represents every IP address in the world, including your private networks. If someone sends a packet that has an IP address, any whatsoever, that's the IP address you allow. Okay, 0.0.0.0.0/0 is any. Okay, we want it to when any network, anybody, any IP wants to come to this network, we want it to go through internet gateway. Okay, we created an internet gateway, and we're saying which internet gateway? This one. Okay, so any IP address 0.0.0, traffic coming through or going out, send it to internet gateway, this one. That's it. And that's it. So what we've done is we've attached the internet gateway to this router, the public router. That then turns it from private to public. 0.0.0 any to internet gateway this. So now when we go to the VPC and we look at the map again, voila, you see there's a link there. See? So from here, this subnet can send traffic through here to this, into the world. Okay, there's a link now. Any questions? We can do it again next time. But the thing is, you have to practice this. If you go,
so is that network? So that network is available now. So
it's available to the world. Yes.
We what will be the address, the URL?
Oh no, it's just a network. There's no server in it.
There's no server in it.
There's no, because when you are accessing a network, you don't access the network. You access a machine in the network.
Right.
Yeah. So because you can't just come into the network and say well, you can if you have a VPN, or if you want to create a tunnel, it's different. A tunnel is like now UK and France are linked together via a tunnel. Anybody who goes through that tunnel is going to come out of France. So those are tunnels that you create. Okay, tunnels, and it's always going to be open, and anybody can, of course, at the end of the tunnel, we do some security there, but that tunnel will be created. So if we create an empty tunnel, an empty network that doesn't have any devices in it, well, it has a router, routers are devices and stuff, but any listening device, any smart device that actually is going to listen, you can't just ping the network on its own. You cannot just check the network. You have to create a tunnel first, and that the tunnel can help you do that. But my point is, currently, the network is there, but I can't give you access to the network, if you get what I mean. So we need to create a machine in the network to be able to access that machine. Yeah. So what we're going to do is we're going to create two machines, one machine in the private network, one machine in the public network. And then I'll give you both IP addresses and tell you 1-2 things to do to connect to the machine and see if you can get it or not. And one last thing, remember when we did a security group or a knuckle? So we have created a network, and at the moment, this network is not secured. By default, we are allowing everything to come in and all that. So for our subnets, we need to go to the network access control list. And for some reason, there's an error. Do you create knuckles, or do I have to create a knuckle and attach?
I think you have to create a knuckle.
Oh, come on. That's why it's good to let AWS do everything for you. All right, let's create knuckles. Right. So I will copy this, and then I'll go to network access control lists. I'll create one, call it public one. That's one. I'll select a VPC. Of course, I know this one. And then I create the knuckle. Yeah. I'll do another one, create another network access control list, which is also this is a security thing. Okay. I'll call it private one. That's one. Select this network. And, yeah. So now if I go to knuckles, I've got two knuckles that doesn't have any association. Okay. So we need to associate those knuckles to a network. So edit subnet association, and then I'll select which one. This one was the public one, so I'll select public one and save. And then I go to the next one, and then I will say edit subnet association. I'll say this is the private one, so I'll save private one. Okay, so I've done that. Let's do security groups as well. Okay, so when you create a network, each network, AWS creates a default security group for you. Okay, and that's the firewall. Okay, but we're going to create one for each network. It's easy that way to manage. Sometimes you can even create for specific application. You can create as many as you want, as I said. Well, there will be a limit. Can't create 1 million security groups. AWS will not allow you. So I'll create one for private one. I will not add any rules yet. I'll just leave it. I'll remove this. I'll not add anything. So this firewall is literally Wakanda. Nothing comes in, nothing goes out. If I attach this to any machine, it will not work. I'll just put a description, private one. Okay. I'll create it. So it's created. Nothing is allowed. As you can see, inbound rules. But when you create it, outbound is also not allowed. Nothing. If I attach this to any machine, that's it, blocked. Nothing. Okay. I'll create another one, and I'll call it. The other one, first one was private or public? Private. Okay. I'll call this one public. One. All right. And I'll put this here. Oh, I didn't select the VPC. Did I select the VPC from the other one? I don't know. Right. For the outbound rule, leave it. Outbound, if I'm going out from this network, don't restrict me. If I'm going out, no restrictions. If I'm coming in, someone is coming in, restrict. So this is outbound rule, and we've got inbound rule as well. Okay, so let's just create this with outbound rule allowed. Okay, so as you can see, all traffic allowed to any destination, any net, any IP. Okay, outbound is allowed, but inbound, nothing. If you're coming in, no Wakanda, nothing is coming in. Okay, I think I may have made a mistake on this one. The private one is attached to a different VPC. I didn't select the VPC. Hey, don't worry. I gave it a different VPC. I will copy this and easily delete. It's easy. Delete security group. Delete. You can't. I don't think you can edit it and put it in a new VPC. Right? So I create a new one, and you need to be careful. You need to select here. As I said the other time, the security group sits in the whole VPC. But you can specify which one for which network. That it doesn't matter. I can use that one security group for everything, but that's going to be like when I allow port 80 on this machine, I'm allowing port 80 on that machine. So why would I do that? Why not create different ones? You know what I mean? So we create different ones. I create different ones. Don't create one for it. So you need to make sure that you're selecting the VPC you want the firewall to sit in. Okay, you need to make sure. And this is, I'm obviously going to leave the outbound as it is. I'm not going to add any inbound yet, and then that's it. Okay. Cool. This is it. We've created a network, and I think it has all the things. So we did a subnet, route table, internet gateway. We did a NACL. We've done security groups. Okay. We are not going to do any pairing of VPCs, not gateway, endpoint services. We're not doing elastic capping. You can create DHCP option set, but that's out of the scope today. We've got 2 more minutes. What I want you to do is to practice this and practice and practice and practice. Okay. But to make sure that these networks are working, we need to put in a machine. Okay. So today we're going to go to where we create machines, and that's another service, EC2. Remember, when you're creating the machine, it needs to be in a network. So without the network, you can't create the machine. That's why AWS gives you a default network, just so when you're creating a machine, you don't have the problem of, and that default network is more or less like opening your door, and putting a 1 million in there. It's literally everybody can come in. They do it so that it's easy for you to practice things, and so the default network is not meant to be used. It's always good to create your own network. So we have created our own network, and we're going to create a machine, which is this one, the EC2 here. Okay, and we'll see what will happen. So this is the tool that creates EC2. It's called EC2, and as you can see, it's a different console to the network console. So this is the network console, and if you go to network console view, that view dashboard, yeah. So this is the dashboard when it comes to the network, and when you go to the EC2 where we create machine, this is the dashboard. It looks different. You can see that it's telling you how many machines are running, how many are not running, how many security key pairs you created, security groups, and we got 5 security groups because it's counting all the security groups in the net, all the networks you've got, and if put that here, no, here. We're just going to launch a machine, a virtual machine. Okay, we just click the yellow. Remember to be in North Virginia. Okay, and we are going to create one and call it public one. One subnet. Okay, so this machine, we want to put it in the public one subnet. Okay, I don't know how good people are here. We can create a Windows machine. It's easy. We can do things easily. There are people knows Windows. I think the Windows machine comes on, and it comes on, and you can just go with username and password and connect to it. RDP, blah blah blah. Should we do Windows? It's going to cause problems. Let's do Linux. Okay, let's do Mac because I know what to do. So Ubuntu. Okay, you put the name of the machine, you select Ubuntu, and here, remember, make sure that this is there. It says free tier. Don't go anywhere if you don't see this. Free. free. Leave it as it is. Don't touch anything else. When you get to here, create a new key pair. Okay, so click this. It will ask you for a new key pair, and you put your. We're creating this for public or private. Oh, come on. Let me see. We are creating this for private subnet. Okay, so I'll create a key pair. I don't want to explain what key pair is today, but I just put the name.
I think it's public.
If you're doing for public, make sure you name the key pair public. If you're doing for private, make sure you name for private.
Yours was public.
Was it?
Yeah.
Oh, well done. Okay, we're doing public then. So we come here, we create a key pair, and then we call it public. Let's select the ED2, okay, not RSA, and leave it to PEM and create a key pair. Now we are selecting that key pair. I'll explain. You see, AWS automatically downloads the private key for you. So when you create the machine, you want to come into the machine. This is the key that you need to come in. Okay, same cryptography thing again. That's the security part as well. This is a security part. Network is using the default, but you can edit the network and select your own network you want to put it in. You see, we are selecting this one. And you can also select which subnet you want to put it in. And as you can see, we got the public and the private. This is where the naming convention comes into play, because else you will not see this name. You just see the gibberish. How do you know it's the public one? Okay, so we select the public because we want it to be in the public. And for the public, we want a public IP address, because public communication, you need public IP address, which is the world IP address system. Okay, so we will get, by default is disabled, you enable it so that the machine will be put into also the world's network, and it will get an IP that is associated to it for the whole world. If you don't want an IP address for the world, don't add it. There's a way to go and attach it, but they add it for here. And it asks you, do you want to use a security group, which is the firewall? Remember, we've already created all of these things. So when we get here, it's easy for us. Okay, we select one. It gives us, we have one for public. We choose that one. Okay, they have additional networking configuration, but we're not going to go there. We leave everything as it is, and then we just click this. Okay, that's it. And then AWS will give you a virtual machine, a server in their data center on the network that you created, that you should have access to. Okay, that's it. And then we click this green link. It will take you to where the machine is sitting. You can obviously work on the machine, manage the machine, and do all sorts. I'm going to obviously 5 more minutes. Let's finish. Let's just do one thing and then we finish. Okay, it's pending. It's pending. It's, I think they are spinning it up. It should have said initializing. Why is it pending? Instance state pending. Pending for what? They've already associated the public IP for us. So this is the IP address. If I want to connect to it from the whole world, this is IP address. In the network, this is the IP address the network gave to this machine. Within the network, if I want to talk to this machine, I can use this IP address. Within the network is known as 172.19. See, it's in the same range, 123.29. It's a random number that is picked and given to the machine. And this one is also random, that is picked from the world's IPs and is given to it. But it says pending. Is there something wrong somewhere? Is it pending? Oh, running. Okay, so it's running now. Okay, so if you select it, you get more details about the machine. So this is the IP address. This is the network is sitting in. This is the subnet is sitting in. This is the public IP, the private IP, all the key that you yourself you need to go in. Okay. Now there's a machine there. How do we make sure that we can go in or not? This is where we test the network. So we have the machine. It has its own public IP. That means if I connect to this IP, remember every URL is behind an IP. So if you know the IP address, you can use it directly. Remember, every URL, gov.co.uk, is sitting behind a machine which has one of these. Okay, and that's what we call DNS, domain name resolution. We're not doing that today. But if I hit this, I'm saying connect to this machine on port 80 in a browser. And the browser will try, it's not working. Okay, it's not working. The port 80 is closed. The machine has a security group attached to it that has port 80 closed. Okay, so it says not working. There's nothing there. So one security is that the security group have blocked everything. I'm not sure if we blocked everything at the knuckle part. So let's go to network access control list. We haven't. I think we just left the network. So everything is allowed in the network. Where's the network part there? If you go to network access control list and we go to public one, check the details of public one, look at the inbound. We say all traffic, deny. We have denied everything coming into this network in the public one. And we have also denied, I think, inbound is deny. Okay, so and outbound is also deny. Okay, so you see, basically in this network, every machine that comes in, every traffic that comes in that has any IP address, we have denied it. Denied it. So for public, we need to allow that. Okay, so we edit the route table. So what we're doing is we're configuring the router to say just let people in. Okay, edit and the deny. So we're going to add a new rule, and we're actually going to say all traffic, any network, allow. Now, these are rules. What happens is AWS will go through this. Let me save. Oh, we call it, let's give it 100. Okay. So rule number 100. Okay. For rule number 100, when the traffic is coming, we say for you, AWS will check the first rule first, and then it will then process that rule and say first rule is 100. Check that rule first and apply that rule and stop. Don't go any further. If you didn't find what you're looking for in this rule, go to the next one. If you didn't find it, go to the next rule. So that means I can put a lot of IP addresses here and say, for this network, if I can create a new rule and say rule number, I can swap the rules as well. So I'll make this rule number 200, and I'll make this rule number 100. And I'll say, I'll put my own custom IP of AWS does allow me to choose my own IP. Port, and you specify which port as well. I can actually say all ports. Can I actually do that? All ports, every port. And I can say my own IP just for me. If the request is coming and it has this IP, so you know how to get your IP, my IP address. You can find your IP address by typing what's my IP in your browser, and your browser will give you your IP. Yeah, what's my IP? It's not coming to do. This is my public IP. Where's my private IP? My IPv6. What's my IP? Let's go to this browser. This browser is done. What's my IP? Right, let's go to this website then. There it is.
Okay, I think you can use oya.net.
I found it in the end. I didn't want to. Google used to be able to give it. Anyway, this is my IP address. So I can copy it. And I'll say, you see, it shows where it's in UK, in the world as well. This is my browser, my router IP address. Okay. So I can go to my network that I was making rules and say, for my IP address, and you have to put 32. 32 means that this IP and this IP alone allow. Yeah? Allow it. Oh. Port range. Okay. I'll put 21. AWS says what? 21. Port range must be a number between 0 and this, or two numbers separated by this. So I'll say port 0 to 65535. 0 to 65535. What they are saying is which port range is allowed that your IP address can come into this network. Yeah. So I save it. Now, the reason why I added my IP is that I want to look at this. You see, because I put this 100, the two, so they will look at the 100 first. Is the packet, does it have this IP address? If it's true, then don't do anything else. Allow him in. If it's not true, go and check the next rule. Does the packet apply to this? Yes. Okay, then allow them to in. If it's not true, go to the next rule. And the next rule says deny everything anyway. Okay. So this is how you can manage your network, by allowing people on specific ports to come in or not. This is it in AWS. This is how you do it. So this list can be a long list. And this is what some people call whitelisting or blacklisting. So this IP address has been whitelisted on this network. And if I want to blacklist it, I just put deny. So I can actually edit and deny this IP address not to come to this network at all. Blacklist it. It's blacklisted. But if I allow it, I have whitelisted it. Okay. That's it. So for this network, this IP address from my house is allowed. That means that if I use any other net, it will be allowed as well, because the next rule allows anything. So if I don't want anybody else to come in, I just delete the next rule. But this has become a pain, because then I have to then give specific IP addresses to specific. There are networks that are like that actually. People literally have to put your specific IP address, you and you only, nobody else can come in. So I can actually remove the next rule, the rule 100, I can remove it. If I remove the rule 100, the rule 200, it means that in this network, only this IP is allowed. That's it. In this network, only this IP is allowed. That's what it means. But I don't want to do that. You can play around with it yourself when we finish. So I will cancel this. And then in the public, we have allowed inbound, and the outbound is also denied all. So what we have to do is, because we want to be able to go out as well, we have to add a rule, and we will say rule 100. We'll allow all traffics. Everybody is allowed. Yeah. Everything going outside of the network is allowed. We just add one rule. Okay. So we're not going to configure the router for the private. We'll just do the public for now. Okay. So what we have done now is, now the network comes in via the internet gateway, and is going through this router. And this is the router we are configuring, saying who and who cannot or yet can come in. This is what we're doing here in this network. Okay. And when we finish, we have to go to the security group and say, okay, who can come in or can't come in as well in the security group. Okay. So we can go to the security group. It's a lot more work, man. That's why. Go to the security group and find the security group. This is the public one. And for the security group, I'll just say everybody can come in for now. Okay. That one too, I can actually just allow my only IP. So I can say, okay, this is a custom one, and I want my IP. So AWS here has ability to actually take your IP and put it there for you. Boom. You see, my IP is actually 90. This is my IP address. So okay. Where is the public router again? Let me copy this. The port range 0, I think port range 0 means all ports. I think. Manage inbound rule. Yeah. Custom port range 0, custom, everything. TCPI. Yeah. I think it's, yeah. So now I've got my IP. Let me go to the NACL. Public NACL, edit route. I don't know how I put 51 there. The tool that told me my IP address was wrong. I can also find it from my command line as well. I can find my IP from command line as well. And says if config, and my IP address should be here somewhere. Paul, help me. Is it okay? So these are my private IPs. Is it IP config?
IP config, yeah.
IP config can be for Windows. No, it's a Windows thing. Windows. Okay, well, don't worry. I know who knows. Check public IP Linux on Ubuntu. And they'll give you a command. There we are. There we are. There we are. I hope this works. Basically, you can find your IP address using different type of tools. There it is. Don't know what's going on. This is the IP address. All right, let me add both. Let me just add both. That's it. I'm just trying to block my network so that only me can come in. So if it's playing up, I'll just add both. So I'll add another rule. Rule 3. I'll make this 300. I'll make this 200. And that also, all traffic, all ports allowed. Oh no. And then I'll put this IP address here, 32. Allow. Okay. So what I've done is in this route table, I said, check the first rule. If it's this IP, allow. If it's not, check the second rule. If it's this IP, allow. If it's not, check the third rule. If it's this IP. So I can remove this one and test it. Let's remove the one that allows everything, and let's test this one. Okay. Now, in the security group, we have to also do the same. So I'm just going to go to the security group, the public security group, because if you get it in the network and the security group also says ping ping, then there's no point. So add custom, and I'll add this. Don't know why I've got 2 IP addresses, but hey. Okay, so in the security group, I've also said allow everything to this IP address. Now, there's a port called ICMP. Okay, ICMP port. Okay, what is ICMP protocol? You need to learn. It's for pinging a machine. ICMP is ping. So the Internet Control Message Protocol, ICMP, is a set of rules. Protocols are rules that devices use to communicate data transfer errors on the network. ICMP is a network layer protocol that uses network devices such as routers to send error messages and operational messages. So this port allows you to just ping a machine and say, hey, are you there? The machine needs to come back to you and say, yes, I can hear you. That's all you can do. You can just ping it and say, hey, are you there? In that message that I'm pinging, I'll send a packet that says, are you there? Okay. Look, and this is it. You say echo. If those villagers here, when you go to the village and you do echo, and it comes back, echo, 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 you're echoing. So, and in that echo, you're saying, hey, are you there? Yes, I'm there. So this is a port that does that. Just allow any machine has opened that port for you to just come and say, are you there? Actually, and he says, yes, I'm here. there's nothing else you can do in that. It's a protocol. You can't bypass that protocol. Okay. So if I have access to the machine, when I echo, they should respond back and say, yes, I'm there. Okay. That's a way to test if you have access to a machine or not, if your packet can get to the machine or not. Okay. So what we do is we take the IP address of the machine, this machine, and we're going to ask, hey, are you there? Okay, because there's no server already installed on the machine, and so we can't check if the port 80 is working, port 90 is working. We're just going to, at the moment, we've allowed every port from my IP address. So if we ping the public IP, we should be able to, the machine should be able to respond and say, yes, I'm there. Okay, so then in my Linux machine, I will ping it, and I'll just ping IP. And it's asking question and it's not responding. Okay, so it's sent the bytes of data and the response hasn't come, meaning that the network is not public. There's something wrong somewhere. Something is failing somewhere that I need to fix. Now let's cancel that. This is when, if you don't configure your network well, you get into problems. So it's not easy, guys. So let's cancel this ping, go back to the network, and just open for everybody. Let's open for everybody and see if the ping will work or not. Okay. So I'll go to the security group. I'll just edit the security group, and then I will delete these, and I'll say just allow everybody, all networks, anybody anywhere. Okay, and AWS tells you that, hey, this thing you're doing, you're going to allow any address, IP address, to come in. Okay, that's the security group open to the world. Okay, that's the public one, and that's what we attach to the machine, didn't we? And then we go to NACL, the network level, and also remove these and say, let everybody come in, remove, and let's add one rule that says 100, any network, everything allowed. Okay, so we have then also changed this. So the firewall we changed, we allowed everything, so there's no fire. We quenched the fire, the wall, everything can come in, and in the network level as well, we said everything can come in. Okay, so if you look at the inbound rules, everything can come in. Outbound rules, everything can go out. I know what's going on. In the security group, did we configure outbound rules? Let's see. Okay, we've done that. Okay. Right, now let's ping again. Moment of truth, and then we can finish. Let's say if the machine is there and it's responding. So we didn't do the network right. It's saying, hey, are you there? I say, yes, I'm here. This is me. And this ping thing will continue saying, are you there again? Yes. And then this is the response. It will stop at the end, or you can cancel it. So from my machine in my house, we can send packets to the machine in AWS, and the machine in AWS is responding to us. Okay, I will put this machine now thing in the WhatsApp, and then you can also ping it as well if you want to ping it, or you can do yours as well. But I'll delete the machine soon. But this is the problem, isn't it? What we want to get to is that the networking to allow specific IP address, whitelist specific IP address or not. It's not just easy. Okay. I made some mistakes somewhere, but I'm not going to fix it today. When we meet again, we will do it. Okay. But at least we have a machine in the network that we can access from anywhere. I've said the IP to you. You can also ping it. Okay. Ping it and see if you get response back or not. Can you ping from browser? Can browser ping? What's the ICMP port is what? What is there? It's port what? It's not going to tell you the port. What's the port number? Port number. It has no concept of ports. Oh. ICP port is 0. Okay. What port is 7? Okay. Well, this protocol is literally a protocol to just, every machine is listening. If someone says, Echo, hey, are you there? They will respond and say, I'm there. Okay. So that's how it is. Anyway, can I ping in a browser? Because if you don't have Linux, ping in a browser. Browser ping, yeah. Someone has a software that does the browser ping. So you just put you have to accept cookies. You have to, what's it pinging? Browser ping. What's this? What's going on? Ping test. Ping test. Okay, yeah, you can ping. So let me put the IP address here and ping it. I want people to be able to ping it without having to use Linux. So let's ping this. Invalid URL. It only pings URL. Anyway, guys, let's leave it here. What we've done today, let's recap, is that we now have secured, well, we haven't secured, we've put measures in place that can allow us to block access, allow access to different ports on different machines, on different networks. We have added internet gateway. If I remove this internet gateway now, the ping will fail. This is the things that you need to go and test yourself. What he said, is it true? Now I'm pinging it, it's responding. What if I detach the internet gateway? So let's try again. Ping, it's working, okay? I cancel, go to AWS and remove the internet gateway. So go to internet gateway and detach it. You can detach from VPC. Okay, it tells you that your resources will not be communicated to the internet, blah, blah, blah. But is it really true? Okay, so it's network VPC has some mappings, public access, please unmap them. It doesn't even allow you to just detach. It wants you to remove some things first before you detach, because it's got public access. So let's say if I enter here, was it the knuckle on the route table? Was a route table that has route to the internet. They don't want you to add this to it. You have to remove this first. So in fact, let's just remove this. Okay, remove this here, and let's ping again and see if it will work. So we remove the route to the network and then ping. Ooh, can't get to the machine. Can't get to the machine. You want to ask if he's there or not. Can't get there because we have removed the route to the internet. But if I was in the network, I could ping it in the network. Okay, so play around with these things. This is free. The machine is free. You can leave it there. It's free, but it's free for some time, I think. So make sure you delete it anyway. Any questions? Let's stop here. 9:30. Wow. If you don't ask questions, it means that I'm 100%. I'm so good at teaching that everything goes in.
I think it's the kind of thing needs to
Practice.
I mean, for myself, it needs to be practiced. So
Exactly. Practice. Remember, when they teach you like this, it makes sense. All makes sense. Tomorrow, if I tell you to do it, you'll be like, oh, where do you have to click to do this? Where do you have to click to do that? Now, the good news is we have tools that we are going to learn, something like Terraform, Ansible, all of those two, Puppet, Chef, that we are going to learn that will make this easy if you know how to develop the code. You can do all of this by code. Okay. And then that code will manage it. That code will go and check the state. What is the state of my network? Has anything changed? What's the state when I created it to the state now? Has anything changed? And if anything has changed, do I want to add the changes to the code or do I want to delete the changes? And you apply using code and everything is happening in AWS. That's what we call configuration management. And Kobe, when we're in places where we were, when I saw you physically, we were talking about an issue where in Azure, things are not being able to push there. And this might be the reason. Okay, because things has gone to Azure, people have put security measures in there that blocks easy access like that. So we could look at these things as well. So I think when I come back, we can have time, just me and you, and look at that issue and see how it goes. Yeah?
Yeah.
Cool. All right. Let's stop this and go and practice, guys. I will definitely share this video on YouTube today. Okay? Google takes about 30 minutes to get it ready, and then I will literally upload it to YouTube and share the link with you. But I'm rushing for the airport. So I haven't even got my bag down. So I'm going to Rwanda and I'm rushing for the airport. So if it's delayed, don't worry, I will definitely share this one. And then what you have to do is just watch it. You can skip it up and down here and there and practice. And when you do, just do it yourself as well and say, okay, I'm creating a network. This is the insider block. This is this. I'm attaching this, and go and create a piece and EC2 in it. Even if it's got access to everything, before you can put an EC2 in a machine, in a VPC, it has to have all the things that we created, and then you have to be able to ping it. Find a way to ping. You can ping from Windows, you can ping from Linux, but it has to be command lines, which is the CMD command. Okay, you have to ping. Some guys here are very good at doing these things, like Alphonse and Jean-Luc. If you want, just ask them a question, and Paul, ask them a question how they do pinging from Windows, how do you do ping from browser, what tools are they using to ping, and then they will tell you, and then you can also ping as well. Thank you very much, guys, for joining. I'm really happy that you're here for me to teach you. Makes me learn more. We will meet again next week, possibly. Next week is possibly, because on Saturday, I think my flight is later in the day. If that is the case, then we'll do the morning. If not, it will be the following week. Okay, so but I'll inform you all on the chat. Anthony, let me go and pack, and if you have time, and I also have time, we can do something, yeah? Or tomorrow morning or tomorrow night. I will definitely be in Rwanda, and guess what? When I'm in Rwanda, I have time to my hands because I don't have Joshua there. I don't have Joshua or Florence there. I don't have to. Sharon does all of it. So and Joe. And so I will have time on my hands in the hotel to do a lot of things.
Yeah, all right. I'll connect with you later.
All right, cool.
Let's talk later.
All right, cool.
Thank you. Safe
Thank
flight.
you. Bye.
Okay.
Yeah, bye-bye.
Thank you. Bye. Bye.
Joshua, do you know that this whatever you're doing behind me goes in the meeting, in the call?